Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
We assume that's the Bahamas. 544 miles per hour, 46, 56 degrees.
I'm Janice. I'm excited to be able to talk about science on screen about the Martian. I started thinking about the movie, and specifically this Martian, Mark Watney from the movie. When you think about this movie, the first things that come to mind in terms of science for most people are these next items. A lot of people are concerned about the radiation that the astronaut would be exposed to. I'll talk a little bit about that. The trajectories of the different approach and escape from Mars. The windstorm, of course, is probably the most scientifically questioned piece of this story. Making the water, the food, being able to grow his potatoes, the habitat breach, the hydrazine, the launch off Mars, and then his spacewalk, extravehicular activity. But my equation doesn't have to do with any of those. So my Martian survivability equation looks like this. It's a little complex, but I'm not sure if you're aware of the Drake equation. But the Drake equation is a way to estimate the number of intelligent civilizations in our universe. And it starts with a very big number, the number of solar systems in the universe. And it progressively gets smaller into the number of planets around those solar systems, and then the number of habitable planets in those solar systems. And therefore, it's continually decreased, the number. So using that as my starting point, I came up with different variables, starting with what I think is the longest thing he has to deal with, the largest amount of problem is his exposure to the Martian atmosphere. This is a very hostile environment. Not only the atmosphere, the temperature, the gravity, the amount of work he has to do to survive on a daily basis, and the sunlight that's different from, of course, Earth. He's on the planet for this length of time, or in extra-Earth orbit for this amount of time. So then that becomes part of the equation, how many days he's on Mars. Then I have a graphic here of what the extent of a Mars mission would look like, just to kind of give you a little bit of insight into some of the actual things that are required. This book is very scientifically accurate, and so many of the things that are discussed could happen. It's just how likely are they to happen. So then the next parameter is, for me, the water. And because in the book he actually is able to make water, my premise is that would he be able to keep it? So for water on Mars, it's a very dry environment. So being from Minnesota, I'm sure we're all aware of how dry environments can really affect our lives. And in the book, it is mentioned that it's a dry place. The quote is that the water in it was able to quickly evaporate from the airflow and low pressure, in referring to the blood when he's injured. So I estimated a number here that I think would result in his losing some of the water he worked so hard to make. So then the next part in my equation is the potatoes. How well would he be able to get viable potatoes out of this instance? So I looked at a couple of examples. there's a lot of discussion about how much sunlight is available to the flora on Mars. Would you really get viable seed potatoes out of a Thanksgiving dinner? My example really that, I don't know if a lot of you remember the Biosphere 2, where there were 8 people that survived on 2,000 square meters, and that lasted about 2 years. And it wouldn't have survived without outside intervention. Another study I looked at talked about microbial growth and how they tried to simulate the Martian environment, and of the bacteria that they tried to survive, 1 out of 22 of those bacteria survived. Now that's a Martian environment and not the HAB, but still, that's maybe a generous number for Mark. Okay, this is the biosphere that they did 2 different experiments with. One lasted 2 years and one lasted 6 months. No, 6 months. Okay. So then Mark has to survive on 1,500 calories a day. How likely is it that he's going to be able to do that for 900 days? So I have 2 examples that I want to talk about, Poon Lim and Henry Worsley, and there's my number. I won't get too much into that. So if you go to the next slide, we have Poon Lim. He was a castaway, lost at sea for 133 days. I think in a pretty similar environment to Mark in that it's isolated, very little food, very little water, and very extreme in terms of the environment. He did survive 133 days at sea alone. Henry Worsley also has similarities to Mark Watney because he did a solo exploration of Antarctica crossing, and he has similarities to Mark because the environment is extreme, the temperature is extreme. He has to work, they ski like 12 hours a day, and he has to take in something like 8,000 calories a day in order to do that. He did not survive 71 days of that environment. The next parameter is how, it's very much related to the last one. How much would a person, a human, be subjected to pressures where they may have an error? And so then I try to estimate that. And I looked at a lot of different studies about solitary confinement, sensory deprivation, and how altered circadian rhythms may impair our judgment. How some of these people, they had a distorted sense of time. Their normal reactions were dulled, and some of them hallucinated and became paranoid. So in these 900 days, would Mark experience something like this? And the chance that one error would be disastrous would be high. And so my example here is the Mars Climate Orbiter. And the Mars Climate Orbiter, I don't know if you remember, was the failed Mars mission, where by one accidental calculation, they did not estimate the units correctly. They used English instead of metric. If you could go to the next slide. The orbiter actually came closer to Mars than was expected due to that error. And at this 57 kilometers, that's where it burned up. Okay, so then another variable is how much cancer risk would he have had he survived all the way to the rescue? So this is pretty close to the end because he'd have to survive all those other events first. It's very much a concern to current Mars exploration and anything pretty much beyond our close Earth orbit due to galactic cosmic rays. Anyone would be exposed to a large amount of radiation, enough to cause concern. And the Ares crew, all of them would be subjected to this exposure. It's quite a variable number, but it's about 1,200 microsieverts. So the chance that you'd get cancer, you'd be at an increased 5% risk. And then I have a slide for this, which you can see the moderate risk here at 1,000 microsieverts. And then, of course, radiation exposure is very different. There's chronic versus extreme exposure. But the chances would be pretty high that that would be a problem. So then finally, my last variable is X. And I call this X because I think there's all the stuff that we don't know. Actually, JFK talked about it, and I'll quote him here. He says that the vast stretches of the unknown and the unanswered and the unfinished still far outstrip our collective comprehension. So this is one of the things that I worry about. Is a person like Mark Watney so arrogant that he wouldn't think about something and would overestimate his own abilities? So I took that number and I multiplied it by 0 because it wouldn't get you anything. But then again, it also wouldn't really necessarily lose you anything. So what is X then? And I read that many of the astronauts thought the book was about 98% correct. So that leaves about 2% error to what we don't know. So then X equals 2%. I don't know if maybe we can't see it. There we go. Okay. So then if we put that all together, Mars survivability would be all these numbers multiplied together. I didn't do any exponents. And you get this value. So then, would Mark survive his Mars mission? And on the next slide, we can see that he's got about a 1 in 10 billionth chance. And in the words of Mark Watney himself, I'm pretty much fucked. That's my considered opinion. Fucked. That's my presentation.